It's fine. So in the last class, last in the sense it's day week before, so we were discussing that particular point where what are the concepts that are required to solve a problem of a Rankine cycle on the regeneration effect. Okay, so if the regeneration is being imposed on the Rankine cycle, what are the different concepts that you need to know so that you can solve the problem comfortably? Okay, so I will just highlight that particular points once again. Please do listen these. These are very much important when it comes to regeneration of a Rankine cycle problems. Okay. So the first thing what we have learned is the value of M. So the value of M, how do you calculate? It is the mass of steam bleeded divided by the mass of steam entering the turbine. So may I know the value of, suppose, just for example, two things I would take. The one thing is the mass of steam bleeded. Suppose the mass of steam entering the turbine, which is this. So the mass of steam which is entering the turbine, suppose it is 10, and the mass of steam which is bleeded, if it is 5, can I know the value of M? If the mass of steam entering the turbine is 10 and the mass of steam which is bleeded is 5, so what is the value of M? Yes. How do you calculate the value of M? M is the ratio of mass of steam bleeded divided by mass of steam entering the turbine. Now I am saying you the mass of steam entering the turbine is 10 and the mass of steam which is bleeded, which is taken out, is 5. So what is the value of M here? Guys, I need a response. First of all, are you able to hear me? It is very simple. Okay. So in regeneration, you must calculate the value of M. Without it, you cannot even solve the problem. Now, how do you calculate the value of M? So M is given by the ratio of mass of steam bleeded divided by mass of steam entering the turbine. That means, what do you mean by mass of steam bleeded? In the sense, it is that particular mass which is being taken out at intermediate of expansion. Middle ಅಲ್ಲಿ ತಕೊಳ್ಳೋದು ಎಷ್ಟು ವಾಪಸ್ ತಗೊಳ್ತಿರಲ್ಲ ಅದು m. Okay, that is the mass of steam bleeded. Now what is mass of steam entering the turbine? So this is the mass of steam which is entering the turbine. So now I am saying you the mass of steam which is entering the turbine is 10 and the mass of steam which is bleeded taken out in between is 5. Can I have the value of m?
0.5.
Oh, thank God. So it's 0.5. So everyone got this concept. How do you calculate the mass of m? I mean the value of m? Any doubts in this?
No, sir.
No, sir.
Okay, this is very, very important, man. One problem will be pakka from the regeneration. I am telling you this. Okay. That is done. That is one concept. Concept number 2. Always remember this particular diagram, PV diagram of the regeneration, where with one feed water heater, what happens? We always consider that one would be entering. That means one amount of fluid would be entering the turbine. M is the mass of steam which is breathed. We already got to know how do you calculate it. So if one is coming like this and M is taken out, so whatever the remaining thing is, 1 minus M, correct? Right? Out of 1, if you take out M, it is 1 minus M which is remaining, which is going to the another stage of expansion, right? 5 to 2. Got it?
Yes, sir.
Same, your 1 minus M amount of steam will come like this, will undergo pumping and merge here and merge here. Isn't it? Same 1 minus M amount of steam. Now, whenever there is a problem on regeneration, always you have to focus on this particular point here. That is the state number 6. In this state number 6, I am calculating what are the different inflows and the outflows. Okay, what is the inflow? Can anyone say? How many inflows and how many outflows for the state number 6? How many inflows and how many outflows? So one is coming from the bleeding steam. This is one inflow which is coming in, and one is coming from the condenser after pumping work. Correct? So one was coming from where? One was coming from state 5 and another is coming from state 7, and one thing which is outflow which is going out to reach state 4. Now you say me how many inflows are there and how many outflows are there for this particular state number 6. Siddesh BN. Siddesh,
Sir,
how many inflows are there and how many outflows are there when you consider state number 6?
one inquiry, sir.
Yes? Yes? Srijan,
Yes, sir.
Amog, Srijan, please tell me how many inflows are there and how many outflows are there?
Uh, Inflows, 2, sir. Inflows 2, outflows 1.
So can you name the inflow from which state is coming?
5 and 7.
So inflow is coming from state 5 and another inflow is coming from state 7.
Yes, sir.
Okay. And one outflow is reaching to
4.
4. So this is very, very important. In this case, why I am telling you all this? Because you need to apply energy balance at state 6. So how do you apply energy balance at state 6? Remember, it is mass flow rate into enthalpy of that particular state. Mass flow rate into enthalpy of that particular state. Please understand this. Okay, now I'll take green now. So Sujan told me that there are two inflows, right? This one, and there is one outflow, which is this. For inflow, it is positive. For outflow, it is negative. You have to calculate MHs, that is mass flow rate, Mahendra Singh Dhoni. Okay, MH, you have to calculate M into H for all the inflows and the outflows and then sum it up to get the energy balance. So how do you do that? I'll just explain you. Okay, now if I want to apply energy balance now, okay, energy balance. So how do I apply it? Come on. Now, considering state 5. So what is the mass of the steam which is coming from the state 5? What is the mass of the steam which is coming from state 5? Yes, please do respond, guys. Please do respond. What is the mass of steam which is coming from the state 5 is my question.
M.
M. So it is M dot, not M dot, M into. It is coming from the state 5. So it is H5. Now, it is inflow. So should I take it positive or negative?
Positive.
So it is positive. So this is done with the state 5. Now tackling one more inflow. So which is coming from state 7 this. Which is coming from state 7. Okay. So now how do I write it? What is the mass of the steam which is coming from the state 7? What is the mass of the steam which is coming from state 7? State 7 in the sense it is this. What is the mass of the steam which is coming from state 7? What is the mass of the steam which is coming from state 7?
One minus M.
So it is 1 minus m, mass flow rate is done, into enthalpy. So it is coming from state 7, so it is at 7. Now, since it is an inflow, should I take it positive or negative?
Positive.
So it is positive, correct? Next, now last one, which is an outflow, we'll just discuss it. Okay. Now, this is the outflow which is reaching the state 4. Now, what is the mass of this steam which is going out to state 4? Anyone? What is the mass of the steam which is going out to state 4?
M plus 1 minus M.
Yes, exactly correct. Here it is m, which is coming in, and here it is 1 minus m. So I should add these two. If I add m plus 1 minus m, so what will be the mass of the steam which is reaching state 4? If I add m plus 1 minus m. Uh, From here it is m, which is bleeded, and 1 minus m is coming from the condenser. So now I need this particular mass of the steam which is going to state 4. What is that value?
1.
How did you get 1?
M plus 1 minus M. M cancel.
Exactly. So these two masses, both the inflows has to be added so that you'll get a flow which is going out to reach the state 4. So m plus 1 minus m, so it is 1 there. Now, so I will take the mass flow rate as 1. It is reaching to the state 4, so I would multiply it by H4. Now, since it is an outflow from the state 6, whether should I take it as positive or negative?
Negative.
Negative. So, according to the energy balance, whatever it says, this particular whole summation, whatever we have dealt, it yields to 0. It comes down to 0. Okay, so this is how you apply energy balance for a regenerative Rankine cycle. Is that clear? Any doubts in this? Any doubts? Have you understood how do I apply the energy balance onto the state 6?
Yes, sir.
What about others, man? Respond, no?
Yes, sir.
Okay, guys, are you able to see the screen and voice? Voice is clear.
Yes, sir.
Yes, sir.
Yes,
Okay,
sir.
fine. Okay. So please do give me a confirmation that you have understood this, because without understanding this, you will never be able to apply these concepts onto the problem. Simple man. At the state 6, you should add whatever the inflows multiplied by the enthalpies. You should subtract all the outflows reaching those particular enthalpies, M into H values. Clear? If any doubts, please let me know. Okay. Yes or no, man? Should I repeat it once again? Okay. What about others, ma'am? Are there in the class? So totally 30 people, 35 odd are there. Only 2 to 3 are responding. What about others? Guys, take this seriously. So from now on, whatever the classes we take, please do attend and involve in the class, because classes would be online. You already know that exams definitely would not be online examinations. It would be offline. That is 100% sure. That is pretty much very known fact. So since vaccinations drives are being conducted, vaccinations everyone has been taken. From the next semester, definitely the classes would start. Okay, in an offline mode itself. Even the examinations for this particular semester would be conducted in offline, and there will be no compromise or no liberal nature while evaluation. This particular fact we have already experienced in your third semester. Am I right? Am I right or wrong?
Yes, sir.
Yes, sir.
Okay, so that's why please do not neglect the subject. Okay, I'm not asking you to study for 6, 8 hours per day or study for 2 hours continuously for weeks. I'm not asking all those stuff. I'm just insisting you to involve in the class and solve whatever we have been solving in the class. That is more than enough. I'm assuring you that. When you have YouTube videos will be there, I'll be giving all 5 modules notes with you. But the thing is, just by referring the notes, how many of you are comfortable in understanding the concept? Say me that, especially which is related to ATD. I don't know about other subjects, I'm talking about my subject. How many of you can grasp just by seeing the notes, you can understand the concepts? How many of you? It's really hard, man. Okay, so on the parallax effect of it, if you just understand whatever is being taught in the class and solve 1 or 2 problems which is being dealt in the class along with me, definitely there is no requirement of even another textbook nor another sort of explanation. So you'll be very much comfortable in solving the problems just by one time revision. Hope I am clear with this. My expectation is whatever we are solving in the class, please do involve and solve. It might be for 40 minutes or 30 minutes, but please do involve and solve. That would help you in a lot and more extent. Is that clear? Whatever I have said.
Yes, sir.
Yes, sir.
Okay. So just man, whatever we are solving in the class, please solve along with me. That's it. Nothing more else. Okay. If I ask you some value, please calculate it and give me, so that the problems whatever you will solve, you'll be having a comfortable factor with it. You'll get to know the parameters, you'll get to know the concepts and how to solve it, and things becomes easier. Okay, no need to study for 6 and 7 hours per day. Nothing requirement. Just 40 minutes per day, ATD class enough. Is that clear? And everyone are with me in this?
Yes, sir. Yes, sir.
Now, this is how you calculate the energy balance and stuff. Okay. Now, one thing is there now. So, in all these energy balance, okay, in all this Rankine cycle, okay, can you see me where is the pumping work? From where to where is the pumping work?
6 to 4.
3 to 3 to
7.
exactly. So it is from 3 to 7. So from here to here is the pumping work, right? Very good. So now, if in the question he says neglect pumping work, if in the question he says neglect pumping work, then can I say the value of H7 is equal to the value of H3? Because pumping work is neglected, this whole sort is neglected. Can I say H7 would be equal to H3?
Yes, sir.
So then what can I do is I can just write M cross H5 plus 1 minus M. Instead of H7, I would write it as H3 minus H4, which is equals to 0. So this forms the energy balance at 6. Is it clear? Why I have done this? Because if in question he says neglect the pump work, then I would replace H7 with the value of H3. Is that clear? Yes?
Yes, sir.
Yes, sir.
Okay, now we will solve immediately a problem on this to get to know whatever we have learned and apply whatever we have learned now. Okay, please do copy this. Okay, so in this case, first immediately draw a TS diagram which is related to a regeneration Rankine cycle. So the steam turbine is fed with steam having an enthalpy of 3100 kilojoules per kg. So before getting into the depth of the problem or reading out the problem, what I will do is I would just draw a regenerative Rankine cycle like this. Okay, so what I would do is I would take this out. Okay. Fine. Fine. So this is a regenerative Rankine cycle which we are supposed to deal with. So first he says what he says. The steam turbine. I hope everyone has copied the question, right? Correct?
Sir.
Anyone? Fine. So this is a TS diagram. So in the question he says the steam turbine is fed with the steam having an enthalpy of 3100 kilojoules per kg. Okay. So what is this 3100 kilojoules per kg? Which enthalpy is this? I know it is enthalpy, which is pretty much given. So he says it is the enthalpy of steam which is entering the turbine. So which one it is? Whether it is H1, whether it is H5, H2, H4, what is that?
H1.
So it is the value of H1 which is being given in the problem. Very good. It moves out of the turbine with an enthalpy of 2100 kilojoules per kg. We pretty much know that the turbine expansion happens from state 1 to state 2, and it says the enthalpy of a steam which is coming out of the turbine is 2100 kilojoules per kg. Now, what is this value? Whether it is H5 or H2 coming out of the turbine, he says. Yes. Whether it is H5 or H2 or H1, what is that? 2100.
H2.
It is the value of H2. Very good. Next, the feed heating is done at a pressure of 3.2 bar. So this is very important. So feed heating is, in the sense, this is the feed heating. So what I would do, I would just change the color and I would write this particular pressure is how much? It is 3.2 bar, which is given that. With the steam enthalpy of 2500 kilojoules per kg. So what is this enthalpy? It is nothing but the value of H5, enthalpy of the steam which is heated. That is how much? 2500 kilojoules per kg. Next one. The condensate from a condenser with an enthalpy of 125 kilojoules per kg. What is this? A condensate from a condenser, he says. So that means we have to focus on a condensation process. Condensation process happens from where to where? Condensation process happens from where to where? 4 to 1, 1 to 2, 2 to 3, 3 to 4. What is that?
Two to three.
Yes. Very good. So condensation process happens from 2 to 3. Now he says condensate from a condenser has an enthalpy of 125. Then in the sense, should I take it as the value of H2 or H3? What is it?
H3.
H3. Very good. So it is H3 value is given as how much? 125 kilojoules per kg. Excellent. Now, enters into the feed water heater. Now, the quantity of the steam bleeded is 1120 kilojoules per kg. Okay, so I would just write whatever he has given. Quantity of steam which is bleeded. How much it is? 11200 kg per hour. So this is the quantity of the steam which is bleeded. Now, next, find the power developed by the turbine. So now he says what? He is asking us to find what? Power developed by the turbine. That means WT he is asking us to find. Okay. Assume that water leaving the feed water heater is the saturated liquid at 3.2 bar. That means he says it is nothing specifying that water leaving the feed water heater is nothing but it is the state 6. It is on the saturated liquid line. That is his point of saying. Okay. And the heater is direct mixing type. No need to worry about it. There will be only one type of heater for you. Okay, no, there is no different types of heater, so no need to worry about it. He says, neglect pump work. So, pump work happening from 3 to 4, 3 to 7. If it is happening from 3 to 7, if he says, neglect the pump work, then what inference can I draw from this? What inference can I draw? So this particular work is neglected. So if it is neglected, what inference can I draw? Yes?
Directly from 3 to 6 it goes. 7 we have to remove.
What is the inference? What? Okay. So if
But
he neglect the pump work, can I say H7 is equal to H3? Can I say it? That H7
Yes,
is
sir.
equal to H3 because this particular value of pumping work is being neglected, right? Understood? Now, so H7 is equals to H3, which is equals to 125 kilojoules per cube. Yes?
Yes, sir.
So now I would take this, okay, and can I have this value in kgs per second so it would be comfortable for me?
Divided by
Anyone?
3600.
So please do that. So can I have the value in kgs per second?
kg per second.
3.1.
3 point?
3.11.
3 point?
11.
3.11. Oh, fine.
3.11.
Okay. 3.11. Now, so the power which is being asked, okay. So what he has asked is power developed by turbine. So this particular thing, how will you calculate this? That is equals to mass flow rate of steam entering the turbine. So what is the mass flow rate of steam entering the turbine? Cross work output from turbine. Okay, so how do you calculate this? So work output from the turbine is WT. Now, WT in the sense, come back to the PS diagram, whatever we have. So in this PS diagram, turbine work output is from where to where? Yes? Turbine work output is from where to where? From which state to which state?
5,
Yes?
1 to 5 and 2 to.
Very good. So it is in the two stages where it is 1 to 5 and 5 to 2. So can I just write it as W 1 to 5 plus W 5 to 2. So turbine work is given by two stages, W1 to 5 and 5 to 2, right? Correct? Yes or no, man?
Yes, sir.
No. So here, now mass flow rate into enthalpy, 1 to 5. So what is the amount of mass which is entering here? Which is this. The same thing here is coming. Right? What is the mass flow rate here? 1 to 5. What is the mass flow rate?
1.
Very good. So it is 1 into, here it is, now, enthalpy difference, 1 to 5. For work it is initial minus final. So I should take it as enthalpy difference.
H1.
Exactly.
H1
So it
minus
is
H5.
H1 minus H5. So this is done for 1 to 5. Now for 5 to 2, which is this? 5 to 2, which is this? Now what is the mass flow rate which is coming here? 5 to 2. 5 to 2, mass flow rate.
No.
So it is 1 minus m. Now 5 to 2, what is the enthalpy difference? Initial
H5
minus
minus
final.
H2.
H5 minus H2. The same thing I would take there. Okay, I would write it there. So here, I will come back here and write the same thing. So work done by a turbine is equals to H1 to H5 plus it is H5 to H2. Two stages of expansion is being taken out. So for the first stage 1 to 5, the mass flow rate is m into it is H1 minus of H5 plus initial minus finals. For the second stage, it comes down to 1 minus m into initial minus final H5 minus H2. So, do I have the value of H1, H5 and H2?
Sure. Yes.
Do I have the value of m? M is nothing but it is mass flow rate of steam bleeded divided by mass flow rate of steam entering the turbine. Do I have this value with me? Do I have the value of m? Do I have the mass of steam bleeded? That means I have this particular value. My question is, do I have the value of m? Yes or no? Sujan, Harshit, Azim, Ashir,
Yes, sir.
Anish, Sohan, Rakesh. Do I have the value of m?
No.
M
No,
value
sir.
ಕೊಟ್ಟಿದ್ದಾರೆ ಕ್ವಶನ್ ಅಲ್ಲಿ.
ಹಾಂ ಸರ್.
ಕ್ವಶನ್ ಅಲ್ಲಿ ಕೊಟ್ಟಿರೋದು ಇದು ಮಾಸ್ ಫ್ಲೋ ರೇಟ್ ಆಫ್ ಸ್ಟೀಮ್ ಲೀಡ್ ಕೊಟ್ಟಿದ್ದಾರೆ. ಎಂ
ಹೌದು ಸರ್.
No.
ಇಲ್ಲ ಸರ್.
ಅದನ್ನ ಹೇಳ್ರು ಬಾಯ್ಬಿಟ್ಟು. So therefore we need to calculate the value of M. So if I calculate the value of M, so I will be in a position to calculate the value of turbine work output, isn't it? So that is overall funda. So how do I calculate the value of M? Is by energy balance equation, which is applied at state 6. Okay, so if you have learned the concepts which is taught in today's class, please do apply the energy balance equation at the state 6 and get me the value of M by the next class. Is that clear? Only M would be unknown there.
Yes,
You
sir.
can easily get it. Will you do that? In Obne na irado class le.
Yes, sir.
Yes, sir.
Muro.
So PV is equal to MRT.
Oh, energy balance equation, man. This particular equation which I have taught you.
Okay.
Okay, there only M would be unknown. You know all the other values. Since neglecting the pumper, you know the value X3 also. Will you calculate in the next class? 4 responses I have received. Bearer line badikidara satidara.
ಇಲ್ಲ ಸರ್ ಕೇಳಿಸಿದೆ.
Yes, sir.
ಓಕೆ ಸರ್, ಓಕೆ.
ಓಕೆ 6 7 ಉಳಿಕಿದ್ದವರು 8 9 10 11 12 Okay, so by the next class, good. Please do solve this, and I'll be checking everyone's notes, each and everyone's notes. So you must have the value of M with you by applying energy balance. Is that clear? So we will continue the problem in the next class. Please do mark your attendance in the Google Sheet. Have a nice day ahead. Take care.
Thank you, sir.